ABO grouping. There will be exam also. As you know, yesterday I didn't consider the marks, but today I will update the marks. Okay. So coming to the ABO grouping, listen. There is one famous false statement. The statement is we all have same blood. That is not real. Okay. We don't have same blood. If that is the case, whole might be better place, but that is not the case. So we all have different types of bloods. And one interesting fact, until 19th century, everyone thought we all have same blood actually. They thought that we all have same blood. And they understood the significance of blood also actually. Okay. Whenever the people cutting animals will bleed and they are dying. So they thought blood has something that will keep us alive. So we must have blood. That lost blood must be replaced to keep us alive. So they understood the role of blood, but there are some problems. The problems are, so they amputated a hand. So once we amputated, what happens? The patient started bleeding. So immediately what they thought, they bring a goat. Okay, they slaughtered the goat. And they started inserting goat blood into the human. So they kept a pipe into the human blood vessel. They started, transferring blood. So these things has been really done. They tried with goat, they tried with, pigs, everything, monkeys. And now the thing was, there is a 90% death rate. 90% chances that you will die. Only 10% we might survive. So yes, there is a problem. So they want to identify an approach to uniform this blood grouping or blood transfusions. Okay. So now what they did in 20th century, there are a group of immunologists. These I will discuss later, immunologists. Meanwhile, what they did was, rather than using animals as a backup for blood transfusion, let us use humans, human to human transfusion. Let me take one human, okay, he will give blood to other human to human blood transfusion. So now the death rate has been decreased, human to human. Now the death rate has been decreased to 40%. So now 60% chances for a successful transfusion, but still 40% is a very large number. It is just like a 50-50 chances. So she got injury, I tried to give her blood to her, and she might stay alive or she might die. And these are the blind approaches we are taking for blood transfusions in the old days. You just imagine when you are alive in those days. It's very painful. Everything is on the blessings of God. So this is the problems. Then came a scientist. So he did some really fantastic in vitro studies. So what he did was, rather than directly giving her blood to the patient, he did a small experiment. He took a glass slide, he took her blood, 2 drops of donor blood and 2 drops of recipient blood, and he mixed it on a slide, and he saw, is there any reaction or not? If there is reaction, he stopped the transfusion. Got my point? He took 2 blood groups, the one who will give and the one who will receive. He mixed it on a slide and he saw reaction. If there is a reaction, he stopped giving blood. If there is no reaction, he is going for transfusion. Okay. Now I want to say this technique. When we mix any 2 types of blood, if the blood reacted, the blood will be broken down. Okay, broken milk, right? Sometimes milk will broke. I hope you know this, right? Similar word. So this concept is called as, this phenomenon is called as agglutination. Agglutination. I don't want to go there. Actually, agglutination means resulting in an agglutination. You just remember this reaction is called as agglutination. Okay, so this scientist's name was Carl Landsteiner. Carl Landsteiner. So Carl Landsteiner doing his basic experiments. He still didn't standardized. He just adopted a new way of understanding transfusion reactions. So he took 2 human bloods. He's seeing whether there is a reaction or not. No reaction, fine. Reaction, don't do any transfusion. So suddenly, with this approach, the death rate has been reduced to 20% and success rate increased to 80%. But still, there is a death rate. We need 100% safe blood transfusions. So now, he started working on with his data. He is doing this experiment on a large population. He did for 1,000 people. Then he started seeing some patterns in the people. He started seeing some patterns in the reactions. So what patterns he observed was, there are 2 types of people. All humans are categorized into 2 types. He felt maybe red blood cell has 2 types of antigens. He felt it based on the statistics. Keep in mind, this is just a blind game. By that time they don't know molecular markers, they don't know nothing actually. So just blindly based on huge 1,000 people data, he assumed there might be only 2 candidates for these reactions. So he felt RBC might have 2 antigens. Maybe RBC have 2 types of antigens. It can be an antigen A or it might be an antigen B. He thought red blood cell has 2 types of antigens. Humans have 2 types of antigens. Maybe some humans have A antigen or some humans have B antigen. Is it clear? Antigen concept clear, right? So I just want to add one more point here. When I said immunologist, the way immunologist approach is always antigen plus antibody. So what is the meaning of antigen and antibody? Very simple. If I give you something, your body creating something against this one, that is called as antibody. Say for example, I have given you a pollen grain into your blood vessel. I introduced a small pollen grain. You know what is pollen grain? A small sand grain. Okay, I introduced a small sand grain, assuming this is an antigen. Then immediately body responded. Body's immune system responded, and body has created antibodies against this antigen to neutralize it, or to kill the antigen. That antigen can be a virus, a parasite, bacteria, anything. So our body always responds with its own proteins. They are called as antibodies. Clear? So now you know what is antigen, what is antibody, and you know Carl Landsteiner's approach. So Carl Landsteiner doing blind studies on people. He is doing this experiment, taking 2 drops of blood, donor and recipient, and he is checking a reaction. That reaction is called as agglutination. Up to here clear? Yeah. Antigen and antibody. See, if anything entered into our body, okay, that foreign material can be attributed as antigen. Anything that entered into our circulation is an antigen. Now our body will create a, maybe I can say, our body creating a bullets to shoot the antigen. Okay, that bullets are antibodies. Bullets and the interesting property of antibodies is they are very specific in their nature. For example, assume antigen was a tuberculosis. So body will develop anti-tuberculosis antibodies. If we got a malaria, body will prepare anti-malaria antibodies. So antibodies are always specific in their nature. They are not randomized antibodies. Antibodies always specific in nature. Maybe I can say if I have a shooter antibody and I am telling this a shooter to only shoot Julita, so he will only target Julita, not all the students. Yeah, so antibodies are very specific in their nature. Don't worry, don't take it personal. So now it's clear, right? Alright. So, where are we? Antigens. Right? Red blood cell has 2 antigens. Now, Carl Landsteiner has identified 2 antigens in humans. They are antigen A and B. Clear? So, yes. CR. Alright. So, alright, see students. So, he has categorized human blood groups into 4 types. Listen. The groups are, if red blood cell has A antigen, this group is called as A group. If red blood cell has B antigen, this group is called as B group. Some red blood cell has both A and B antigen. This group is called as A and B group. Now, some individuals don't have any group. They don't have A and B antigen actually. Some red blood cells don't have any antigen. Such group is called as O group. This is what he observed and he given ABO grouping. This system is called as ABO grouping. ABO grouping. Literally, after standardizing ABO grouping, after discovery of ABO grouping, the success rate became 97% and death rate fell to 3%. See, so that is the power of statistics and observations. Okay, so Carl Landsteiner has observed there are 2 antigens on a red blood cell. Based on these 2 antigens, the groups has been classified into 4 groups. What are the 4 groups? A group, B group, AB group and O group. This is clear, right? This is what the antigens. Based on the antigen available on red blood cell, the groups are 4 types. Is this concept clear?
Yes.
Any more doubts? No, right? Yes. No. There came another problem. So people are happy. He got Nobel Prize for the discovery. See, Nobel Prize is the the large what you can say, the highest honor one scientist can get. And he got a Nobel Prize for this discovery because he saved millions of people. The death rate has been fallen to 3%. Now there is a daunting problem to the Carl Landsteiner, that is resolving this problem. Still there is 3% death rate, and how to resolve it. So he got Nobel Prize and he is working on this problem for next 10 years. 10 years he didn't get a solution. So he is publishing papers. So one day, on one fine day, what happened? There is another scientist who is working on Carl Landsteiner's problem, that is 3% problem. That scientist's name was Alexander S. Weiner. There is another scientist, his name is Alexander S. Weiner. Weiner or Weiner. So what he observed? He said he was always, Alexander working on monkeys actually. He's working on monkeys and he observed grouping of monkey blood. He's working with monkey's blood. Okay. What he observed was monkeys has a 2 types of blood group system. Not 4 groups, only 2 groups. Either monkey blood is positive or they are negative. Monkeys has these 2 types of grouping system. And this scientist working on a monkey called rhesus monkey. RHESUS, rhesus monkey. By the way, rhesus monkeys are common street monkeys in India actually. They are very common. Whatever monkeys you are seeing on streets in India, they are rhesus monkeys actually. So they are very common monkeys. So it's easy to capture them. So he's working on rhesus. I made a mistake. Landsteiner didn't get Nobel Prize, but he's working on this 3% problem. Landsteiner didn't receive Nobel Prize. I said a wrong thing there. Okay? Then, so Alexander approached Landsteiner. He said, Mr. Landsteiner, you are correct, there are 4 groups in humans. But I observed another grouping in monkeys, that is positive and negative. Let us work on human groups. Let us take this monkeys antibodies, RH antibodies, and let us work on humans. Then they understood even humans have positive groups and negative groups. Now they have updated their classification. Now Karl Landsteiner and Alexander Weiner together, they have made a hyper classification, a standardized classification, that is 8 group ABO system. What is this? Sir, I need some water. Did anyone know water? I know I'm contradicting lab water, but I'm here. Anyway, where am I? ABO grouping. Now listen now. Now they did like this. Group A, it might be a positive group. If it has a RH antigen, it will be a positive group. If it don't have RH antigen, this will be a negative group. Same thing for B also. B positive, B negative. Same thing for AB. AB positive, AB negative. And same thing for O. O positive and O negative. Hence we got 8 groups ABO classification system. This is called as ABO blood grouping system. Is it clear? So this is how they have standardized it. Literally the death rate has been reduced to 0.01%. For every 100 transfusions, there is a, even one patient won't die, but the patient developing minor problems, and that there is a 0.1 chance of death rate, and they worked on this also. That is a next generation scientist problem. Not only ABO grouping, there are subtypes, subgroups actually, A1, A2, B1, B2, AB1, AB2. So there are other subgroups. That is not our problem actually. We need not to study that complicated things. Up to here, is it clear? What? If RH antigen present, that will be a positive group. If RH antigen absent, that will be a negative group. Clear? Yeah. So now you have understood RH and ABO antigens. Now, there are some rules about transfusion. I want to discuss those rules. Listen very carefully. This is called as Karl Landsteiner law. So laws have their own beauty. Where is your mask and very good. Correct. Yeah. Karl Landsteiner law. He given a very beautiful law. First write down the law, then I will discuss what is it. He given only 2 line statement. Very interesting. He said, if a particular agglutinogen, that means antigen, agglutinogen present on the surface of RBC, if a particular agglutinogen present on the surface of RBC, the corresponding agglutinin, this is a term for antibody actually. The corresponding antibody must be absent in patient plasma. See how beautiful this statement was. So he published an article, and the abstract of the article is this, Karl Landsteiner law. My law was, if an antigen present in a patient RBC, corresponding antibody must be absent. If you can't understand this, I will elaborate this statement. Listen, if an RBC has one particular antigen, the corresponding antibody, that means anti-A antibody must be absent in the plasma. What is the reason? If that is present, it will self-destruct the antibody present, this antibody will attack the antigen. Got it? Hence comes this table, the classical table you are seeing on textbooks. This one will be antigen on RBC, and this row will be antibodies in plasma. So now I will keep group A, blood group A. What antigen present here? In group A, antigen A is present. And what antibody is present? This is antigen. And what antibody will present? Antibody B. So I will write here. So A antigen will have the opposite antibody. B antibody presenting B antibody is present in A blood group. Whereas in B blood group, what antibodies will present? A antibodies will present in B blood group. What about AB? Since both antigens are there, nothing will be present. As per the law, if particular antigen present, corresponding antibody must be absent. So no antibody is present here. Then coming to O group, since there are no antigens, the corresponding antibodies will present. A antibody and B antibody present in O group. This is the complete classification of ABO grouping. What antigen present on a surface of RBC and what antibody present in plasma. Is this story clear up to here? Is everything clear to everyone? Yes, Mr. P. That means Pradeep. Clear, right? Very good. So now, yes. In AB, no antibody is present. Absent. Antibodies are in AB. Definitely antigens are present. That's why it is AB group. Why it became AB group? Because it has A antigen and B antigen. And antibodies are absent in the plasma. Clear? Yes. Very good. Now you understood this one. This is very important. The reason was, imagine by this analogy, imagine patient, the recipient is A group recipient. His blood group is A group. That means what is his status? He has an antigen A and his antibody will be B. Yeah, now I need to tell this rule of transfusion. The rule was, write down here, rule 2. Very important. This second rule was, the recipient should not have antibodies, targeting donor cells or donor cell antigens. Have you understood what it says? Recipient should not have any antibodies targeting donor antigens. That means if this donor has a B antigen, game over. What happens if I give B blood group to A blood group? It will agglutinate, right? Donor was B blood group. I given B blood group to the A blood group. Now A blood group has B antibodies. Now they will attack these cells. Game over. These cells will be agglutinated and he will die. This is the second rule. Clear? Now there is one interesting exceptions. I will let you know. Can I give? So by this statement, what you are understanding? So A group must get A blood group, right? A should receive A group blood. Am I correct? Now let us see one interesting case. Can I give O blood group to this person? Why? Because O don't have any antigens, A and B. But he might have a B antibody to attack, but they can't attack these cells because they don't have any antigens. So we can safely actually. Okay? Any others can receive O group. That's why O blood group is called as universal donors. They can donate blood to anyone because no one can attack these cells. No other blood groups can attack these cells. Is it clear? Now you understood, right? Why O group is called as universal donor? Clear, right? Then I will tell another interesting case scenario. Assume our recipient is going to receive blood and our recipient is AB positive. AB positive. Okay. Can he receive, this individual can receive blood from anyone? Got it? Because he don't have any antibodies to attack. AB positive person don't have any antibodies, so he can accept any blood. What my point? See, by by justifying rule 2. What is rule 2? Donor should not have any antibodies targeting recipient cells. Here, donor don't have any antibodies to attack any recipient cells. So he can receive O group, A group and B group. Okay? Never confuse. Sir, A group might have B antibodies. These B antibodies can attack this B antigens of AB group, right? You might have that doubt. Do you understand my doubt? When I am giving A group to AB individual, A group will have B antibodies. These B antibodies can attack partial B antigen of AB person. Why that is not happening? Why it is not happening? Because simple, the ratios. These antibodies will be dissolved. We are just giving 300 ml blood in 5 liters of capacity. So antibodies will be dissolved and they can't do any effect. There will be no effect on recipient. That's why the golden rule is donor should not have attacking antibodies. Recipient might have antibodies but no issues. From simple we went to very complicated grouping now. Is everything clear? Yes. I think Bisenga has issues. Yes, Bisenga. Where are you confused? Huh? Nothing. So everything clear to you. So now you have understood the concept of universal donor and universal recipient. So universal donor group always will be a O group and recipient will be a AB groups. So this is rule 2. Then rule 3 I need to add to this story. Rule 3. Listen, the rule was, I think I need to tell a message over how to start it. Imagine we have a normal patient, he got an exposed to an antigen. After 1 week, he developed an antibodies. Okay? This development of antibodies is called as sensitization. Maybe 1 week. This 1 week is called as sensitization. He has sensitized to one antigen. After sensitization, he developed an antibodies against this antigen. This concept is called as sensitization. Now there is one huge threat to this same immunology mechanism. I will tell you the threat. Imagine our recipient is a negative recipient. He is a O negative person. He is a O negative. Usually, I will let you know like this. He is a AB negative person. AB negative person means he can receive blood from anywhere, right? Am I correct? Yes. AB negative can receive blood from anyone because he don't have antibodies to attack. Clear? Now imagine. So what happened was, on the day of emergency, I got a AB individual only, AB group only, but the person was AB positive. Can I give this blood positive blood to AB negative group? What is your thoughts? Listen, I want to say one important thing. Since he is negative, that doesn't mean he will have RH antibodies. That is not the case. That case is only for ABO antigens, but not for RH antigens. If someone is negative, that doesn't mean they will have positive antibodies. They don't have antibodies. Keep in mind. Can I give this blood to this person? Listen, first time is okay. First time he can receive positive blood. A negative person can receive a positive blood. But now he was sensitized to a positive blood. First time his body has seen a positive antigen. This is called a sensitization. Maybe within 1 month, he has developed anti-RH antibodies. We have introduced antibodies in his body by giving a positive blood. Mimic from this side, I have said. Okay. I think I need to keep here, right? It's not detecting. Very bad. This is not AI detection, right? Anyway, where am I? This is called a sensitization. Now listen, if the same patient receive positive blood again, game over. He will attack the recipient's donor cells. Okay. So the thumb rule was a positive recipient can receive a negative blood. A positive rule 3. Rule 3. Write down rule 3. Rule 3 was a positive recipient can receive negative blood. A positive recipient can receive a negative blood. But at any cost, write down clause. Clause means contradiction. But at any cost, a negative recipient must not receive positive blood. Must not receive positive blood. Alright. So what is the contradiction statement? Rule 3. Positive can receive negative blood, but a negative recipient must not receive a positive blood. What is the reason? That leads to a sensitization in the recipient. The recipient will get sensitized and in future he will develop. This is called erythroblastosis fetosis. Do you know this concept? Yes. Mother was negative mother, but fetus is positive. First delivery. So during delivery, positive blood entered into maternal circulation, that means mother blood. So mother was first time identified a positive group. So mother developed antibodies. Now if the second delivery, pregnancy, if the fetus is positive fetus, that's it. These antibodies will cross the placental barrier and they will attack the baby, leading to HDN, hemolytic disease of newborn. Or simply I will say, how many of you heard that just born baby has jaundice? They get just born baby under UV chamber. This is the reason. Mother developed some antibodies and mother started attacking baby. So that's why baby's blood was broken. Or baby, baby hemolysis happened. So, but there are good treatments. We have a, during gestational period, we can give injection also to the baby. Anti-free antibodies. And that's different story. You understood concept of transfusion? Yes, tableau. Yes, you can. Yes, that's it. Yes, miss, what is your name? Yes, Power, right? Yes,
So I think that the reason.
you reading that?
The reason you say.
The reason?
Yes. The reason why a positive recipient cannot receive negative.
Oh, the reason why a negative should not receive positive blood. Can anyone explain her? Anyone international? She didn't understood the reason why a negative person should not receive a positive blood. Can anyone explain her? Yes, Christy. Tell her.
It's because sensitization and further it can develop
So that everyone can say like that. Whatever. Okay, listen. Okay. So, negative person has never seen a positive blood. Since he received a positive blood, his immune system will detect, it will activate, and his immune system will develop anti-positive antibodies. So he will develop positive antibodies. Next time, if he is receiving positive blood again, these antibodies will attack the cells, leading to complications. Keep in mind, no ICU patient will say, previously I have positive blood but I'm negative, so this time don't give positive. Did any patient say these things? So better don't do these things, that's it, okay. But still, such patients can be recognized by cross-matching actually. That's why we have cross-matching criteria. I will take a recipient's serum and I will take donor cells and I will mix in a slide. Donor cells and recipient serum, and I will see whether there is reaction or not for the same blood group. Keep in mind, for the same blood group. Donor is A positive, he is A positive, both are A positive. I took his cells and her antibodies, but there is a reaction. How come there is a reaction when both of them are same blood group? Might be the recipient has some antibodies attacking donor cells, some other type of antibodies. So this concept is called as cross-matching, that we will discuss later. That is next level hematology. So now you have understood the basic fundamentals of transfusion medicine. That is the second branch of hematology, right? So who discovered the blood groups? Carl Landsteiner. Who discovered RH typing? Alexander S. Weiner. So in which animal they discovered RH antibodies? Rhesus, okay, rhesus monkeys. Alright. And now this rhesus antigen, they given an alphabet that is D antigen. Anti-D. Okay? Rhesus antigen is also called as anti-D antigen. And write down, rhesus antigen, RH antigen is also called as anti-D antigen. So actually what they are doing is, they are going sequentially. Antigen A, antigen B, then they thought there is an antigen C, but after research they came to know there is no such thing as antigen C. They didn't replace the next antigen, they eliminated C and they went for next one, that is the D. RH antigen as D antigen. That's why this is called as D antigen. Is it clear? Yeah. Now let us see how to perform an ABO grouping test. Very simple. If you understand the basics, then you will understand the test. Listen, the test was very simple. The idea is like this. We will take a slide. We took a slide. Now, we have industry-made antibodies. How industry-made antibodies means very simple. I already know Manpreet's blood group. blood group was A group. Let us assume she has a A group. So what I did was, I took her blood and I introduced her A group blood into a rat. Why I introduced into a rat? I will let you know. Now, rat immune system will develop antibodies against A. Rat will develop antibodies against A group, A antigen. Got it? Now, I will take this rat blood in a test tube. I will centrifuge it. Then I got a supernatant and the sediment. This supernatant will have antibodies. What antibodies I will have? Why are you confusing with me? That is humans. This is an experiment in a lab. Now it will have A antibodies. Okay. Now I will take this as a reagent. That reagent is called as anti-A reagent. That is this one. Universally, actually antibodies don't have colors. Universally we have standardized blue color for the A antibodies. These are known A antibodies. Known A anti-serum. This is called as anti-serum A. And the color of anti-serum A is blue. So this is reagent 1. A antibodies reagent. Then we have second reagent. Same process. I understood that Gerrier has B group. I introduced Gerrier blood in a lab, and I took the supernatant of rat. Now this is B group, B antibodies. This reagent is B antibodies suspended reagent. Internationally this was color coded as yellow. This is called as anti-serum B. Anti-serum B. Simple. Now we got 2 reagents for our lab test. Then third one. I came to know that Miss Mimi was a positive person. Not emotional. I was a blood positive person. So I took a positive group, introduced in a rat, and took the supernatant of rat serum. That is anti-D reagent. What is the color of this reagent? Colorless. Okay. You can't say that's why it is colorless. Okay. So D is anti-serum D is colorless. Anti-serum D was colorless. So now you understood how we got these reagents. These are known A antibodies, known B antibodies, and known D antibodies. Or proper antibodies, these are called as RH antibodies. Am I correct? RH antibodies are called as D antibodies. Clear? This is a positive antibodies, RH positive antibodies. Colorless are RH positive antibodies. Yellow is B and blue A. Yes. Now see. So I have taken an unknown blood sample. I have taken 3 drops of blood sample on a glass slide. Let us assume this is our Manpreet's sample and this is B positive group actually. We know this is a B positive group. Let us assume. Clear? Manpreet was worried. Anyway, don't worry, this is a hypothetical. Listen. So now we added 3 drops of Manpreet's blood. Or it might be an unknown blood. Then what we will do? Now to the first drop I added anti-serum A. To the second drop I added anti-serum B. And to the third one I added anti-serum D. Blue color reagent, yellow reagent, and colorless reagent. Ideally what should happen? B antibodies will attack B antigens, right? Can A antibodies attack here? Will we get any agglutination here? Because Manpreet don't have A antigen, so no reaction here. But in this circle we will have a reaction. Why we got agglutination? Because B antibodies attacked B antigens, leading to a reaction. Then since she is a positive person, we got a reaction here also. So if you you observe agglutination in B and RH, this red group will be B positive. This is called as forward grouping. Reverse grouping I will discuss later. Okay? Simple thing, in forward grouping we are taking patient red blood cells. We are taking patient red blood cells and we are detecting red blood cell antigens by using known antibodies. Okay? Now let us see the pattern of all groups. What will be the pattern for all groups? Okay? Then we will understand. See, blood grouping is very big topic. I think you never saw this much lengthy lecture, right? On blood grouping. Jessica already scolding me. We already know all these things. So I have it's just cursing me. Listen. So keep in mind. So hereafter all slides have the same pattern. Okay. These slides are going to have A here, B antibodies here, and B antibodies here. Okay. Let us see the patterns for A group. What will be the A negative group? Where we will see the agglutination in A negative? Here. What about A positive? A and B. Very good. Here. This is A positive. Very good. Then B negative. Where will be the reaction? Here. B positive. Then huh? Very good. Then O group. O negative. Negative. No reaction. Well done. Very good. Then O positive. Now done. Here. Who said A? Okay. Here we will get reaction. Very good. Then A, B negative. Reaction here. No reaction in the B. Well done. Then AB positive. Here, and here. Very good. Now I will draw one blind slide and you need to tell the answer. Hawa, not Hawa. Hawa, where is Hawa? Now Hawa will tell the answer. What group is this?
AB.
What group is this, right? See? Yes, see, easy, I got you. Oh, I think I need to write here. Then you will say, tell me what is this group?
B negative.
B negative. Very good, Hawa. You understood, right? Now, Julie, what's your name? Julita, right? Now Julita will tell the answer. What is this group? O positive. Very good. Now Simran will tell the answer. What is this group?
AB negative.
AB negative. Very good. Mimi will answer. What is this group? A negative. What is her name? No, she is staring. What is it? Bicycle, right? Tell me this group. This group. AB positive. Tableau, you tell this group. What group is this? B positive. Very good. Tadala, right? Tatenda. What is your name? Chantal. Okay. Tell me this group. Very easiest group actually. This one. O what? O negative. Now Srishtika will tell the answer. This one. Abhishek. Okay. Quayum, right? How to pronounce it? Quayum. Mustafa. That is easy. Yes, Mustafa. Tell me this group. Jariel, tell me this group. Okay. I want anyone. Pradeep, please stand up. Please, Pradeep, please. Pradeep, ये कौन सा ग्रुप है? AB? Negative. Are you sure? Now predict will tell this group. What is this group? Where is Simon? Are Simon is next to predict. Very good. Well done, predict. Simon, tell me this group. Take help from predict. Huh? Be negative. Are what a false confidence. O negative. This is what happens when you sit with predict. Hereafter don't sit. Okay. Acol will tell the answer. You can sit there, Simon. Acol, tell me this group. O negative. What is this group? Acol, what is this group? B. B negative. Mercy, tell me this group. What must it be? I didn't tell you. B positive. Very good, Mercy. Well done. B positive. Who is hiding behind you? What is your name? What? Tatenda. You are Tatenda. Now I call you. What is this group? AB negative. Oh, sorry. Correct. AB negative. Faisal. Faisal. What is this group? Okay. Party Abdullah. Arpita. This group. Okay. So that's it. Everyone. Vidicham. This group. AB negative. Huh? AB negative. AB negative. Very good. Mercy. Will you transfer a positive blood to a negative recipient? Will you transfer positive blood to a negative patient? You will? You won't? Okay. Manpreet, what is Karl Landsteiner's law? That's it, correct, very good. So, Mustafa, what antibody is present in A blood group patient? Antibody is present in A group individual.
So B.
Ria said the answer, right? Ria, you said the answer, right? Wait, I'm telling you. What antibody is present in AB group individual? Takalo, what antibody is present in AB group individual? You don't know. Sad. I was sad now because I took a lengthy lecture. Srishtika, what antibody is present in AB group individual? No antibodies. Oh, then I was confused. Sorry. Correct. What antibody is present in O group? Miss Simran. No antibodies present. Really, you are making me, the opposite.
Yes, sir,
AB present, AB antibodies present, you will go to So now, clear that? So how to perform test? I will discuss some important things in test performing. Listen. So you have taken a mixing stick. So you have taken one stick. So ideally what we will do is, we will take a finger prick. We will keep 3 drops of blood on a slide. Now listen, the golden rule. You took a mixing stick. You added a drop of antibody, anti-serous. When you are adding, keep in mind, you just need to add a drop of anti-sera, from the top like this. Never get in contact with the blood. What happens if you touch the blood? You are contaminating these bottles. If you contaminate, that antigens will float here and you will get negative, false positives and negatives. So never touch the blood drop. You just need to drop it. Just 1 or 2 drops is sufficient. Hardly 1 drop. Clear? That is rule number 1. Never touch the pillar with the blood drop. Then rule number 2. The second rule is when you are mixing, okay, you used this stick, you mixed here. Then you added second drop. You never use the same stick to mix here. What happens if you contamination of A antibodies with B antibodies? So never do such things. You need to turn the stick and mix it. Then take the new mixing stick for the third drop. So never cross-contaminate the sticks. And rule number 3, always label your slide before starting the experiment. You draw 3 circles and label them as A, B and C. Now there is an issue with labeling. What you will do, you have used marker on the upper surface. You draw circles here and you kept a blood drop here. What happens then? The marker ink will dilute with your reagents. Always you need to mark the bottom side of the slide. Mark bottom and add reagent on the top of slide. Got my point? And when you are labeling A and B, usually students have tendency to keep at the center A, B and D. Never do it. You write on the periphery of the slide. If you write here, then you can't see total visualization. Okay. So 3 rules in test. Never touch the drop, reagent to the blood drop. Rule 2, don't cross-contaminate. Rule 3, mark in the bottom side of the slide and label at the periphery. And rule 4, last and final. That is, always keep your slide on a whitish background, on a white paper. Okay, that's it. If you are keeping on a dark surface, you can't see the agglutination. And you need to wait 1 minute to get an agglutination reaction. You need to wait for 1 minute. Clear? Yeah. There is another golden rule. Even after 1 minute, if you don't get any agglutination, that doesn't mean they are negative rules or the opposite whatever we think. You need to cross check under microscope. Sometimes there will be microscopic agglutinations. Sometimes agglutination is not so large to be seen with naked. At that time we need to cross confirm with the microscope. Is everything clear so far about routing? Pradeep, once come here, Pradeep. He is my control for your class. He says right answers and everyone right. Yes, Pradeep. Draw the diagram of being positive.
So can you put digital water on the sample?
Never. Water will hemolyze the sample.
Digital water.
Now, what is smart? Redraw the diagram here. Go positive. Here also he is cheating. Publicly cheating. Is a B positive, Mr. Green. Go positive. Drop. Here be positive. Again cheating. So here, keep your head. That the instincts, the copying instincts are always triggering me. What is that? Maybe positive. But why could we use the 7 of? What at the last circle? Is this AB positive? Is again cheating. Simon, what should we do for Pradeep? Tell me, Simon. He's checking what to talk. Simon, it is your responsibility to make him smart, okay? Yeah. Alright. Get ready for your quiz. Quiz